Bismillah ar-Rahman ar-Rahim. So, this is chapter 23, electrical current. Electrical current. We will cover, inshallah, flow of charge, electric current, voltage source, electrical resistance, Ohm's law, direct current and alternating current, speed and source of electrons in a circuit, electric power, compact fluorescent lamps, light emitting diodes, and electric circuit. So the first thing is the flow of charge. Flow of charge. And the closest analogy for you to understand the electrical current is water. Water and how does water behave usually. Here, the analogy of current, suppose that electrical current, suppose that we have high level of water here and low level of water here. So we expect right away that water will just go from this side to this side, from this side to this side. So the difference in height, we can imagine it as voltage difference. So if you have a circuit and in the circuit there is a voltage difference, then you will expect to have a current. You will expect to have a current. لاحظوا in this method, it's like a battery. It's like a battery that once this level equal to this level, then current will stop going. Here, it's like a generator, like a motor, electrical motor that keep producing electricity in the circuit. So when this level goes down, then the pump will just bring the water again up. So now you can look at it that you have a continuous source of voltage, like a power supply or whatever. And you can think about the water as electrons, so electrons will be pumped again to the higher container, and then you have a continuous current. Electrical current, flow of charged particles. In metal wires, conduction electrons are charge carriers that are free to move throughout atomic lattice. Protons are bound within the nucleus of the atom. And then conduction electrons will move, proton will not. In fluids, positive ions and electrons constitute electrical charge flow. So in fluids, positive ions can also contribute to the electrical current. Which of these statements is true? Electric current is a flow of electric charge. Electric current is stored in batteries. Both A and B is true. Neither A and B is true. طبعا اللي هو part A. Rate of electric flow. Rate معناته per time. Measured in ampere. طيب what is ampere? It is 1 coulomb of charge per second. يعني coulomb per second is 1 ampere. Speed of electrons اللي هي بنسميها drift speed through a wire is slow because of continuous pumping of electrons in wire اللي هو هذا هو اللي بنسميه electrical resistance. Charge flows through a circuit voltage is established across a circuit. Electrical current, we define now alternating current اللي هو اختصارها AC. Alternating current, electrons oscillate to and fro around fixed position. Movement is produced by a generator or an alternator that switches the signs of charge periodically. Commercial AC circuits are used in most residential circuits throughout the world. Can be stepped up يعني to high voltage, يعني we increase the voltage. We increase the voltage, we reduce the current. We increase the voltage, we reduce the current. Why is that? For transmission over great distances with small heat losses. شو يعني الهيت losses? Comes from where? From the electrical resistance. أو step down where energy is consumed. يعني when we transmit the power, the AC power, we increase the high voltage, and when we use the voltage, we step it down to lower voltage. So again, we can step up for transformation or for transmission, or step down when we want to consume it. Voltage sources, conductor, any material having free charge particles that easily flow through it when an electrical force acts on them. Conductor, this is how we define a conductor. Any material having free charge particles that easily flow through it when an electric force acts on them. Electrical potential difference. Difference in potential between 2 points. Charges in conductor flow from higher potential to lower potential. Flow of charge persists until both ends of conductor reach the same potential, or maintained for continuous flow by pumping device. يعني زي الرسمة اللي حكيناها، لأنه high level of water and low level of water, flow charge persists until both ends of conductor reach the same potential, same height, if we have water containers. وبعدين maintain for continuous flow by pumping device. حكينا زي power supply, continuous source of power. نفس الرسمة الآن بعيدها لأنه إيش بده يشرح الكونسبت. Electric potential difference again. Example, water from higher reservoir to a lower one. Flow continuous until no difference. No flow of charge occurs when potential difference is zero. لما يكونوا بنفس المستوى ما بصير انتقال للتيار. الحين he is comparing water with electricity just to make it as imaginable as possible. So here in a water circuit, we have a valve to switch on and off. We have a line, a kind of hose, or the water will transmit in it. And then we have a pump, a valve. Here we have a switch. The line to transfer the water is the resistance, the electrical resistance, and the pump is the battery. Here he draw a voltage source, but the battery will die eventually. So if you want a continuous source of voltage, you put a power supply instead of a battery. In chemical batteries زي هاي البطارية work by chemical disintegration of zinc or lead in acid. Energy stored in chemical bonds is converted into electrical potential energy. إذن من وين جبنا electrical potential energy? From the energy bonds stored in the chemicals of the battery. Current in a circuit is dependent on the voltage and the electrical resistance in ohms. إذا بتتذكروا هناخده كمان شوي قانون أوم، يعني هو بقدم لأوم اللي هو V over I is equal R. فمعناته he is talking about the current in a circuit. معناته I is equal what? Is equal V divided by R. V divided by R. So voltage, high voltage, هذه resistance. وهذا الكرنت. Circuit elements that regulate current inside electrical devices. هاي الرسمة خليني أكبر لكم إياها شوي. هذه يعني لو فتحنا أي جهاز إلكترونيك هنلاقي resistance إما بهذا الشكل أو هذا أو هذا أو هذا أو هذا أو هذا، أو تكون integrated on the circuit board. هاي على فكرة خلية كهروضوئية، هاي بيسقط الضوء هون فبتمرر التيار الكهربائي. What is the symbol of resistance in electrical circuit؟ هاي الرسمة زي ما هو حاططها. طيب now we want to discuss factors affecting electrical resistance. Inversely proportional to cross-section area. يعني thin wires more resistance than thick wires. Directly proportional to length. Doubling the length doubling the resistance. يعني كل ما زودنا طول الواير كل ما زادت electrical resistance. والmaterial rubber for example much more resistance than copper of the same size لأنه أصلا الربر insulator. So إذا عندنا factors. أول واحد خلينا نرقمهم، شو رأيكم؟ 1 2 3. الآن نيجي لرقم 4 اللي هو temperature. The higher the temperature, the more the resistance. The higher the temperature, the more the resistance. لأنه كل ما كانت التمبرتشر higher كل ما كان اللاتس vibration in the lattice of the conducting material is higher. معناته collisions of conducting electrons will face more resistance because now you have more vibration. When you have more resistance بصير electrical resistance higher. Now let's talk about semiconductors. حكينا عنهم تتذكروا زمان المحاضرات السابقة. Semiconductors refers to material that can alternate between being conductors and insulators. Pure semiconductors are insulators. We add impurity to the semiconductor, it becomes partially conducting. Example, germanium, silicon. However, most of the semiconductor used in industries are made out of silicon. حين عندنا superconductors, materials with zero electrical resistance to the flow charge. Flow of charge is without a generation of heat. ما في electrical resistance. يعني electrical resistance is equal 0. هلا high temperature superconductors refers to ceramic materials that can carry much current at low voltage. طبعا تونا كتبنا اومز لو. هذا الاومز لو اللي هو relationship between voltage, current and resistance states that the current in a circuit varies in direct proportional to the potential or voltage and inversely proportional to the resistance. يعني اللي هو تونا كتبناه I V over R. I نكتبها بخط أجمل. I V over R. In equation, current, voltage over resistance. Example, for a constant resistance, current will be twice as much for twice the voltage. For twice the resistance and twice the voltage, current will be the same. Resistors, circuit elements that regulate current inside electrical devices. طيب خلينا نشوف السؤال. When you double the voltage in a simple electrical circuit, you double the عندنا هيها I تساوي V over R. So if you double this, then you double this. معناته الجواب you double the current. Damaging effects of shock result from current passing through the body. Electrical potential difference between one part of your body and another part depends on body condition and resistance, which can range from 100 ohm to 500,000 ohm to 500,000 ohm. الحين we need to know the difference between direct current DC and alternating current AC. Direct current flow in one direction only. Electrons always move from the negative terminal towards the positive terminal. Alternating current, however, electrons in the circuit are moved first in one direction and then in the opposite direction, alternating to and fro about fixed position. This is accomplished by alternating the polarity of voltage at the generator or other voltage sources. هذا ال AC positive negative positive negative positive negative، بينما ال DC it's always fixed at a certain voltage. Commercial electricity in North America, it's an alternating current 60 cycles والvoltage 120. Power transmission is more efficient at higher voltages. في Europe it's 220 volt. US continue to use the 120 because so much equipment was already installed. In Qatar the voltage is 240 volt و 50 هرتز السايكل تبع الالكتريسيتي 50 هرتز. طبعا السبب انه يوروب used 220 لانه more efficient when you transfer the electricity. Converting from AC to DC، طبعا هون يعني there is a question in why don't we use AC all the time? Why we don't use AC all the time? The answer is all the electronic circuits work with DC، يعني either positive or negative. The circuits, all of them work with direct current, so we have to convert AC to DC. عشان هيك كلياتنا بدنا نشحن البطارية. We want to charge the battery. Why? لأنه الباتري DC. All the electronics in the phone is DC, but you need to charge it using an AC source, so you use a transformer. You use transformer from AC to DC. Also, you charge your laptop battery. Why? Because all the circuits in the battery works on DC, and they use the battery to take power from, and you charge the battery. Household current is AC, but current in the laptop is DC. To convert, the converter use a diode, a tiny زي هدول هاي a tiny electronic device، بس هاي light emitting diode، هدول عشان يطلعوا ضوء. A tiny electronic device that act as a one-way valve to allow electrons to flow in one direction only. هلا let's see the process. When input to a diode is AC, output is blasting DC. هذا الانبوت هذا الانبوت. مش عارف ارسم سهم، هي سهم، هذا input. After it passes the diode, this will be the shape of the signal, لأنه الdiode will allow only the positive current to go through. Negative current it will not letting it to go, so only the positive. Slow charging, discharging for a capacitor. بعدين after this we put a capacitor. At the positive signal the capacitor is charged. At the negative signal the capacitor is discharged. So capacitor will take energy from us in the positive cycle and return it to us in the negative cycle. If we put two diodes in opposite direction, then we will have positive, and then the negative will be converted into positive because we put it in the both cycles. So current will pass, and then we put a capacitor. فالcapacitor see charge, discharge, charge, discharge. But as you can see, the discharge here is smaller, so this will look like a DC current. This will look like a DC current. طيب, now what will happen when we switch on the light مثلا, or switch off the light? The light is off, we switched on the light. إيش اللي بيصير؟ An electric field is established inside the conductor. Electrical يعني first we establish an electrical field. When the electrical field goes through the wires, the electrons continue their random motion while simultaneously being nudged. يعني نفس الحركة تبع random motion of electrons in the wire, in the material, will stay the same, but it will be pushed by the electrical field. It will be pushed, a little push by the electrical field. Current is established through the wires at nearly the speed of light, لأنه it's an electromagnetic wave. It is not the electrons that move at this speed. الالكترونز ايش اللي بيصير فيهم؟ الالكترونز will be just زي ما هو قال nudged, يعني pushed a little. electrical field اللي هو that will move almost the speed of light in the wires. The electrical field will move. It will while the electrical field is moving, it will push some electrons, but not the electrons that move at this speed. It is the electrical field that can travel through a circuit at nearly the speed of light. إذن اللي travel in the wires at the speed of light is the electrical field, not the electrons. Not the electrons.